Okay, let's continue. So we saw the definition of rational numbers before this. A rational number m by n for where m and n are integers and n is not equal to 0 is the unique point on the line box such that n times box is m. For m and integers where n is not equal to 0, the symbol m by n means the unique point on the line box such that n times box is m. Okay, so this is the definition of a rational number. Let's continue. Equality of rational numbers. Let's begin. When are two rational numbers m by n and r by s equal? So observation. We begin with the cancellation law. Let a be an integer, a not equal to 0. Let mn be integers, n not equal to 0. Then am by an is m by n. So proof is as follows. So what does this statement mean? Box equals am by an. This statement is same as saying an times the point box is am. So thankfully we can write an integer a times an integer n times box, a point box, to be an integer a times n times the point box. So this is a m, and a is non-zero, so n box equals m, that is box equals m by n. Hence am by an is m by n. We saw that saying box equals am by n is same as saying box equals m by n. Hence am by n is m by n. So we used the crucial property of multiplication of a point by an integer. So here, so we wrote this as this, right? So here we use the crucial property of multiplication of a point by an integer, namely ab times a point box is a times b times box. For example, if you take a point, let's call this point box, we can ask, is this property true? For example, 2 times is ab times box, so 2 times minus 3 times box, is it equal to 2 times minus 3 times box? Is this true? Let's see. So here minus 3 times box will be something like this. So let's say the point is somewhere here, point box, then minus 3 times box will be something like this. So this point is point minus 3 times box, and we want to do 2 times minus 3 times box. So after doing 2 times minus 3 times box, the point will be, so you can say so this is minus 3 times box, and 2 times minus 3 times box will be, this point is 2 times minus 3 times box. This point is minus 6 times box equals 2 times minus 3 times box. So both are equal, right? So 2 times minus 3, so first if you do multiply by minus 3 and then by 2, you are getting minus 6 times box, which is the same as 2 times minus 3 times box. So in this specific case, multiplying by minus 3 first and then by 2 is same as multiplying by 2 times minus 3 in one go. So this is the crucial property. AB times box is A times B times box. We use this here. So AN times box, we simplified it as A times N box. N times A times N times box. So in the proof of the cancellation law, we use this property of multiplying points by integers, right? So we showed the cancellation property. Now we'll move to the main observation. Equality of rational numbers. Let Mn be integers and not equal to 0. Let Rs be integers s not equal to 0. Then M by N equals R by S if and only if Ms equals Nr. So this is the condition for two rational numbers to be equal. So let's see why this is the case. Proof. It uses the cancellation law. M by N equals R by S. So this is same as saying we can, so Sm, so this is same as saying Sm by Sn is same as Ns, Nr by Ns. So and this is a unique point box such that Sn box equals Sm. This is a unique point such that hexagon such that Ns times hexagon equals Nr. So these 2 points are equal. So what does this mean? These points are equal means these two numbers Sm and Nr are equal. So M by N equals R by S if and only if Sm by Sn equals Nr by Ns, if and only if the numerators are equal. The denominators are already equal, so this equality will happen if and only if the numerators are equal, that is Sm equals Nr. So right, so we have restated the equality condition in terms of products. For example, so here's an example. Let Mn be integers and not equal to 0. Then this rational number minus M by N is same as M by minus N. So proof is, this is one way, minus M by N equals M by minus N if and only if we use the same approach, n times minus M by, sorry, minus N times minus M by minus N times N equals n times m by n times minus n. So this happens if and only if minus n times minus m equals nm, and minus n times minus m equals nm is true. Hence minus m by n is same as m by minus n. So there's another alternate proof of equality. Just write normally alternate proof of equality. So minus m by n equals minus, by cancellation law, minus 1 times minus m by minus 1 times n. So this is m by minus n. Hence minus m by n is m by minus n. So this is one example of equality of two forms of writing a natural two forms of writing a rational number. Both of them are same. Both of them represent the same rational number. Minus n, the symbol minus m by n and the symbol m by minus n represent the same rational numbers. Okay. Another example, minus 4 by 5 equals 8 by minus 10. So proof is, in the first way, this is as usual, minus 4 by 5 equals 8 by minus 10 if and only if. So minus 10 times minus 4 by minus 10 times 5 equals 5 times 8. So this happens if and only if the numerators are equal. So minus 10 times minus 4 equals 5 times 8. The denominators are already equal. So this equality occurs if and only if the numerators are equal. That is, minus 10 times minus 4 equals 5 times 8, and minus 10 times minus 4 equals 5 times 8 is true. Hence, the rational number represented by the symbol minus 4 by 5 is same as the rational number represented by the number 8 by minus 10, the form 8 by minus 10. So we also have an alternate proof of equality. Right. So minus 4 by 5 equals, by cancellation law, minus 4 by minus 2 times minus 4 by minus 2 times 5 equals 8 by minus 10. Hence minus 4 by 5 equals 8 by minus 10. Okay. That's all for this part. See you in the next part.